Hey folks, welcome to the next session, which is on the performance tuning. Today we are going to talk about the different ways how we can improve the performance of our ETLs as well as on the SQLs. So I'm pretty excited on this session. It's my favorite topic. So let us start without wasting a time. Okay, so performance tuning overview. So basically what you have to do, you have to identify the bottlenecks and fix them. That's all about the performance tuning, right? It's simple. Let me go to the next slide. Okay, so this is the important slide where I'm gonna tell you or basically explain you like what are the different ways we can improve the performance and what should be the sequence for us to identify the bottlenecks as well. Whenever you feel that your jobs are not running properly, they are taking long time, so start looking your jobs in this sequential way. So first of all, what you have to do, you should identify whether there is a bottleneck at the target or not. Once you identify whether there is a bottleneck at target or not, if there is a bottleneck at target, you fix it. If it is not there, then went to the source. Once you identify whether there is a bottleneck at a source or not, if there is a bottleneck at source, fix it and move on to mapping. So this should be your sequence to identify your session's performance. Basically, first go to target, then go to the source, then check mappings, and then go to the transformation, and then look for the different properties at a session level, as well as then move on to the grid deployments, power center components, and optimize the system as well. So this is how you should go sequentially to understand where is the actual problem, and then you will be able to realize what to fix and where to fix. Moving to the next slide, this I already explained you like how we should approach to identify the bottlenecks. First should be your target, source, mapping, session, and system. Okay, so how you can identify the bottlenecks at every level or at each level. It can be a target, it can be source, it can be a mapping, it can be transformation, session, anything. For that you have to take a couple of approaches. One approach is called as a run test approach or run test session approach. In this session, what you're gonna do, in case if your target table or your source table is a RDBMS, you're going to replace that with your flat file. Basically this is kind of a testing with a different database. It's not a database, it's a flat file. What generally we do, we see that sometime the table itself is a blocking. Either it can be source table or it can be target table. So then we will replace the target table or a source table with the flat file and then see if the performance is improving or it's the still same. If the performance improve with by replacing the table with the flat file, so it means that particular target or source table was your bottleneck. So then we will start working on fixing that target or source table. So that is what the run test session says. The second option for you to identify is the analyze the thread stats. So we'll talk about this in detail. And the third one is monitor the system performance. So there are different utilities. If you're Unix, if you have the Unix, there are different commands available where you can see the performance of, basically you can monitor your performance, whether what is the CPU utilization, how many threads are running, what is the process, what are the different processes are running, what is the input output wait time, and all that information you can get it from the Unix. So these are the different ways to identify the bottlenecks. Once you identify the bottleneck, it's pretty easy to fix it, right? Moving to the next slide. Okay, let's talk about now the second option, which is the analyze thread stats. How we are going to analyze the thread stats. It's pretty simple. There are a couple of and before we dig into this, the thread information you can get it from the monitor. Basically when you run a session, in that session a log is generated and that log contain the thread information. So it basically explain you what was your ideal time, what was your busy time, and what was the total thread time. So it has basically three different type of threads. One is called as a reader thread, the second is called as a writer thread, and the third one is basically your rest of the mapping thread. So reader is basically when it reads the data from the source, writer is when it writes the data to the target, and then you have the transformation thread. So transformation threads is all about the different transformations available in your mappings, and there are different times which it calculates. One of them is like ideal time, busy time, and then you have a run time. Ideal time is nothing but when your job is ideal and waiting for other thread to release that particular thread. Busy time is when your job is running for a particular thread, and the run time is when that particular the job was actually running. So let's see how this looks like. Let me just make a little better. Yeah. Okay, this is an example from one of the session, and if you observe your sessions carefully and if you try to find, so whenever you open a session, you definitely will find these options. One could be your reader, another could be your transformation thread, and third will be your writer thread. And if you observe their time carefully, it will also have the times as well. So there will be a total runtime, total ideal time, and the busy percentage. Similarly, this is for the reader thread, which basically reads the data from your source. Then you have a transformation threads, and then you have the writer threads. In this example, so the total runtime for reading the data from the source was 505 seconds, and the thread was ideal for 457 seconds. So basically it was just busy for 9%. So it means the busy percentage is less. It means the source is not a bottleneck because it was ideal for most of the time. So similarly, your transformation thread, it ran total for 506 seconds and the ideal time was just 1 second. It means 99% of the time your transformation thread was busy, and further if we have multiple transformations, so it will be further broken down. So I had a lookup transformation, I have a sorter transformation, I have a router transformation, and this is the percentage being used by the different transformation, which eventually will come out to be 99.725. So lookup transformation took 25% of the time, sorter transformation took 21% of the time, and the router transformation took 53% of the time. So in this case, if I see my router transformation is the most time consuming transformation, so then I need to see and understand what's wrong with my router transformation, why it is taking 53% of the time or 53% of the runtime while it calculates the thread transformations, right? In that case, I need to see and check my logic. What is the logic written for the router transformation? If I can modify it, pretty good. Otherwise, I need to identify something else as well. So similarly, I do have the writer thread, basically, which says that okay, my total job ran for 507 seconds and the ideal time was 384 seconds. So it was pretty busy for approximately 24 seconds or 24% of the time. This is still okay, but this also can be tuned basically. So now we understand how to identify the bottlenecks with the threads. The thread which takes the most time, most busy percentage, is the problematic thread. It can be your source thread, it can be your transformation thread, and it can be your target thread, which is called as a writer thread. Moving on to next. Okay, so now you have already identified the threads concept, or how to identify a bottleneck with the help of threads. So there are other ways also to identify the target bottlenecks. One of them is basically, let me just close this. Yeah, so one of them is so the next topic is basically how to identify the target bottlenecks, because somebody might not be comfortable in reading the thread stats. So for them, there's another option as well, which is called as identify the target bottlenecks with the help of a flat file. So what you have to do in this case, if your target is a database, it can be any DB, it can be DB2, it can be Oracle, it can be anything. Replace your database with the flat file and try to load the data into the flat file. Let's say when the database was there as your target, the job was taking 20 minutes to run the job. Now with the flat file, it is taking 2 minutes. It's pretty simple to identify, okay, your target was your bottleneck. So replace your database table or RDBMS table with the flat file and write the data into that file to confirm that whether you have a bottleneck at a target level or at other level. And the second is that how to identify the bottlenecks, thread stats, which we already have discussed in the previous slide. Okay, once you identify it, what are the options how you can eliminate them? Eliminate them is, first you have to, if you are writing any query on the target, you have to optimize the query and have your database admins to optimize query for you if you are not able to optimize, because optimizing the query is very important. It really bring down your system performance, system degradation, and it really improves the performance. And the next is that if you have indexes and constraints on your target table, you can drop index and constraints and recreate them, because when you have indexes you are not able to push the data very quickly into the target. So drop and recreate them, and for creating dropping and recreating, use the preload and postload stored procedure options, or use the pre-session and the post-session command option in your target tables. Moving to the next, so these are a couple of more options how you can identify the target bottlenecks. First is that there is an option called checkpoints, and you can increase the checkpoint as well. Use the bulk loads. So the bulk load is pretty important option, but there is a disadvantage as well with the bulk load. The most advantage is that bulk load is basically, if your normal job is taking 20 minutes, bulk job will take just 2 minutes. Whereas the bulk load has a disadvantages as well. The first disadvantage with the bulk load is that recovery is not possible. If your job got failed, you will not be able to recover it from the failed point. So you have to make sure that whenever you're using the bulk load option, most of the time your target table should be truncate enabled. Do not apply the bulk mode option on the tables which contain the historical data as well. That's more important. And the second option with the second disadvantage with the bulk load is that if your target transformation and the mapping is not connected with all the columns which are defined in your target transformation, then bulk mode will not be a good option, because it will insert the data very weirdly into other columns. So for bulk mode to be enabled, you have to make sure that you have connected each and every single column in your target transformation with the previous transformation. So bulk mode is helpful, but we have to use it very carefully. And of course the next one is minimize the deadlocks. You have to make sure that you do not read and write on a same table at the same time. If you are having a parallel session, so you have to make sure that both the sessions are not reading the data from the same table, or both are not writing to the same table. So that's how you will avoid the deadlocks. And increase the database network packet size. For that you have to talk to your admins, or basically database admins, not informatica admins.